Welcome to Understand the Math. In this Calculus 1 video, we're learning how to differentiate products and quotients of functions. We'll start by using the product rule to find derivatives when two functions are multiplied together and work through several examples step by step. We'll then introduce the quotient rule, use it to find derivatives when two functions are divided by one another, and practice simplifying our results. Be sure to download the free guided notes to follow along and work through the examples with me. Let's learn about the product rule and walk through some examples. The product rule is just a way to find the derivative of a function that is the product of two functions. Let's now look at the formula. The derivative with respect to x of the product of two functions f of x and g of x is the first function f of x times the derivative of the second function plus the second function times the derivative of the first function. The product rule can also be written as the derivative of the product u times v, and this derivative is just the first times the derivative of the second plus the second times the derivative of the first. Let's now walk through our first example. In this example, we are going to use the product rule to calculate the derivative. In part A, we are going to be finding the derivative of the function f of x is equal to x cubed times 2x squared plus 1. X cubed is our first function, and then 2x squared plus 1 is our second function. Let's now calculate the derivative. The derivative can be written as f prime of x, and it is the first function, x cubed, times the derivative of the second function, which is 2x squared plus 1, plus the second function, 2x squared plus 1, times the derivative of the first function, which is x cubed. Now all we have to do is just calculate these derivatives. We have x cubed, and then the derivative of 2x squared plus 1 is 4x, and then we have 2x squared plus 1 times the derivative of x cubed, which is just 3x squared. Now what we need to do is multiply everything out. This first product is 4x to the fourth, and then our next term gives us a 2 times 3, which is 6, and then x squared times x squared is x to the fourth, and then we just have a 3x squared left. We can combine our x to the fourth terms, and we end up with 10x to the fourth plus 3x squared. And that's our derivative. Let's now look at part B. In part B, we are going to be differentiating the function f of x is equal to 3x minus 5, that is our first function, times 4x squared minus 3, and that's our second function. Our derivative then is f prime of x, and it is the first function, 3x minus 5, times the derivative of the second function, which is 4x squared minus 3, plus the second function, 4x squared minus 3, times the derivative of the first function, which is 3x minus 5. After you get used to doing this, you can probably not write down this step and just do the derivative in your head. We now have 3x minus 5, and then the derivative of 4x squared is going to be 8x, and the derivative of minus 3 is 0. And then we have 4x squared minus 3 times the derivative of 3x minus 5, which is just 3. Let's now multiply everything out. 3x times 8x gives us a 24x squared. And then minus 5 times 8 is minus 40, and there's an x that goes with that. And then if we look at our second piece, we have 4 times 3, so that's 12x squared, minus 3 times 3 gives us a minus 9. Now let's see what we can combine. It looks like we can combine this term and this term. 12 and 24 is going to be 36, so we have 36x squared minus 40x minus 9. And that's our derivative. It's really nice when you're working with polynomials. When you get to your final answer, make sure to write your answer with the largest exponent first, and then the constant term should be last. Let's now look at our second example. In this example, we are given h of x is equal to x times g of x. We're given that g of 3 is equal to 5, and that the derivative of g at the point 3 is equal to 2. We are then asked to find h prime of 3. Let's start by writing down our function. We are given that h of x is equal to x times g of x. We want to find the derivative, so let's write down h prime of x. Notice that h is the product of two functions. X is our first function, and g of x is our second function. So we'll use the product rule. We have the first, which is x, times the derivative of the second, which is g prime of x, plus the second, which is g of x, times the derivative of the first. The derivative of x is just 1, so we'll multiply g of x times 1. Now what we're going to do is plug in that x is going to equal 3. So we have h prime at 3 is equal to 3, g prime at 3, plus g of 3. Now we can go ahead and substitute in what g prime of 3 is and what g of 3 is. This gives us 3 times g prime of 3, which is 2, plus g of 3, which is 5. So let's see, this is 6 plus 5, so we get an answer of 11. Let's now learn about the quotient rule and walk through some examples. The quotient rule is just a way to find the derivative of a function that is the quotient of two functions. That means we're just going to be finding the derivative of two functions that are divided by each other. Let's now look at our formula. The derivative with respect to x of a function f of x divided by a function g of x is equal to the bottom function g of x times the derivative of the top function minus the top function times the derivative of the bottom function, all divided by the bottom function squared. There's a really nice way to remember this. If we take the derivative of a function u divided by a function v, and we think of the function u as the high function and the function v as the low function, we can write the derivative as low d high minus high d low, all divided by the square of what's below. That mnemonic is right here, and it really might help you remember this quotient rule. Let's now look at our first example. In this example, we are going to use the quotient rule to calculate the derivative. In part A, our function f of x is x squared plus 1. That is the top function. And it's divided by x cubed minus 1, which is the bottom function. Our derivative, f prime of x, is the bottom function, x cubed minus 1, times the derivative of the top function, x squared plus 1. So that's just low d high. And then we have to subtract the top function, x squared plus 1, times the derivative of the bottom function, x cubed minus 1. That's just high d low. And then we're going to divide all of this by the bottom function squared, or you can think of that as the square of what's below. Now we just have to do some derivatives. We have x cubed minus 1, and the derivative with respect to x of x squared plus 1 is just going to be 2x. And then we subtract x squared plus 1. And then the derivative of x cubed minus 1 is just 3x squared. And again, we have all of this divided by x cubed minus 1 quantity squared. Now let's look at our numerator and let's multiply everything out because some terms are going to combine. X cubed times 2x gives us 2x to the fourth, and then we have a minus 2x. Then we have x squared times 3x squared. That gives us a minus 3x to the fourth. And then the last term is going to be 1 times 3x squared, and that gives us a minus 3x squared. Make sure that you remember that this minus term is going to carry over to both terms. And then all of this is divided by x cubed minus 1 squared. Now let's see what terms combine. We can combine 2x to the fourth with minus 3x to the fourth, and that gives us a minus x to the fourth, and then we have a minus 3x squared, and then minus 2x, and all of that is divided by x cubed minus 1 quantity squared. Notice that in the numerator, I wrote the terms in descending order. You just put the highest power first, and then the next highest power until you have all the terms written. It just makes your answer look a lot nicer if you do that. And here is our final answer. Let's now look at part B. In this example, we are taking the derivative of f of x is equal to the square root of x, that's our top function, divided by 2 plus x, that's our bottom function. We're going to use the quotient rule, and it tells us that f prime of x is the bottom term, 2 plus x, times the derivative with respect to x of our top term. And I'm going to write the square root of x as x to the 1/2 because it's going to make it easier to take the derivative if we write it that way. And then we subtract off the top term, x to the 1/2, times the derivative of the bottom term, which is 2 plus x, all divided by the bottom term squared. Now let's go ahead and let's take some derivatives. We have 2 plus x. The derivative of x to the 1/2 is 1/2 x to the minus 1/2. And then we subtract off x to the 1/2. And the derivative of 2 plus x is actually just 1. And then all of this is still divided by 2 plus x quantity squared. Now let's go ahead and let's look at this top piece right here, and let's multiply that out. We have 2 times 1/2 is 1, so our first term is just x to the minus 1/2, and then we have a plus 1/2. X times x to the minus 1/2. Remember that x just has a power of 1, so it's 1 minus 1/2, which gives us an x to the 1/2, and then minus x to the 1/2, all divided by 2 plus x quantity squared. Now let's see what we have. It looks like we can combine this term and this term. So we have x to the minus 1/2 minus 1/2 x to the 1/2, all divided by 2 plus x quantity squared. When you use the quotient rule, most of your time is going to be spent on algebra simplification. I think it's going to be easiest to simplify our numerator if we rewrite it in terms of square root of x. Let's write this as 1 divided by root x minus root x all divided by 2, all divided by 2 plus x quantity squared. I think the easiest way to simplify this is if we multiply the top and the bottom by 2 root x. That is just going to clear out our fractions that we have in our numerator. Our first term is going to be 2 root x divided by root x, and that is going to be 2. And then we have 2 root x times root x divided by 2. The square roots are going to combine, and we're going to get an x, so we have a minus x. And then the 2's cancel, which is really nice. And in our denominator, I'm going to pull the 2 root x out in front, and then multiply this by 2 plus x quantity squared. And there is our derivative. Let's now look at our second example. It's actually not as hard as the one that we just did. In this example, we are given that h of x is g of x divided by x, g of 2 is equal to 4, and then g prime of 2 is negative 4, and we're asked to find h prime at 2. We are given that h of x is g of x all divided by x. G of x is our top function, and then x is our bottom function. H prime of x is going to be x, the bottom function, times the derivative of the top, minus the top, which is g of x, times the derivative of the bottom, which is the derivative of x, which is just 1. And we're going to divide all of that by our bottom function squared. Now what we're going to do is we're going to substitute in that x is equal to 2. So we have h prime at 2 is 2 times g prime at 2 minus g of 2. And we're going to divide this by 2 squared. Now we're going to substitute in what g prime of 2 is and what g of 2 is. We have 2 times g prime. Let's pull this down so you can see it. G prime at 2 is minus 4, minus g of 2, which is 4. And we're going to divide all of that by 2 squared, which is 4. So we have a lot of 4's here. Let's see. 2 times minus 4 is minus 8. We subtract 4. Divide that by 4. This is then minus 12 divided by 4, and we end up with an answer of minus 3. And that's it. You've learned how to apply the product rule and quotient rule to find derivatives of functions that are multiplied or divided. To really master these formulas, make sure you work through plenty of practice problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.